In this chapter, we're going to look at systems of equations, which just means two equations or more. In this lesson, we're going to solve systems by graphing. So let's look at some key terminology first. A system of equations is a set of two or more equations in two or more variables for which a common solution is sought. The next one, when solving a system of equations graphically, we look for the intersection of the graphs of the equation. A system of equations that has at least one solution is said to be consistent. A system of equations with no solution is called inconsistent. If a system of two equations in two variables has infinitely many solutions, the equations are dependent. If a system of two equations in two variables has one solution or no solution, the equations are independent. Dependent, independent, consistent, inconsistent is just another way to classify systems. So now let's start solving. And in this lesson, we're going to focus on solving by graphing of our equations. This is a system, and we're going to graph them. We are going to manipulate each one into slope-intercept form. It's going to be easier to graph that way. Of course, you can graph any method you want to graph. I subtracted x from both sides. And now I'm going to divide everything by -1. You can graph any method. You can graph using point plotting, intercepts. I just like slope-intercept because I like to be able to put it into my calculator and check. -x over -1 is positive x. 1 divided by -1 is -1. So there's my first equation that I'm going to graph. My intercept is -1. And my slope is 1 over 1. So I'm going to go up 1 and right 1. And now I'm going to get my line. Okay, that looks pretty good. Now, let's do the other equation. So x plus y equals 5. Let's put it in slope-intercept form. So y equals -x plus 5. So let's graph our intercept, which is 5. My slope is -1, so I'm going to go down 1, right 1. And now I'm going to draw my line. And what we are looking for is the intersection point, because this is the point that they have in common. That is the solution. So the solution is the single point that makes both equations true at the same time, which will be the intersection point of the graphs. So it looks like I have 3, 2. It's really important when you're graphing to use a straight edge if you're graphing by hand, because otherwise human error or your graph might be off slightly, and that is one of the drawbacks to solving by graphing. We are going to learn how to solve algebraically in the next lesson, but if you're solving by graphing, it's really important that you use a straight edge if you're graphing by hand. Again, you can always put these in your graphing calculator, and there is a way that your graphing calculator will calculate the intersection point for you. If we were to classify this system, because we have one solution, this would be considered to be consistent, and since we have two separate lines, then it would be independent because we have two independent lines. So consistent because we have one solution, and independent because we have two unique lines.